Hi, we're team number 767670, the RoboGearheads. I'm Arjun.
I'm Chaya.
I'm Chayton. We also have a fourth teammate that couldn't be here today. His name's Avi.
We are from Cary, North Carolina, and this is our third year in VEX. We decided to challenge ourselves and improve our coding this year. After doing some research, we decided to partake in this programming challenge.
This year, with COVID-19, we were forced to adapt to new settings. This meant having to do pretty much everything online. However, we were able to overcome those challenges and still make a good robot.
In an attempt to get more organized for the season, we started to store all our code into our own GitHub repository. This way, everybody can access and make changes to the code on their own devices, rather than it all being on just one computer. If anybody makes changes to the code, we go through a process of making merge requests, so that everybody can see and interact with those changes.
In order to keep our code more organized, we put all of our functions in a separate file that we called holonomic class. In here, we included the code for our rollers, our intake, scoring, as well as our driving. Because we defined our functions in a separate file, all we did in our main file was to call the functions with separate parameters that we put in.
On our base, we are using integrated shaft encoders to track the distance and speed. We have 2 extra wheels to help with our accuracy in programming. We use these wheels to help determine the distance in the home row. We are also using an inertial sensor on the base to make more accurate turns on the field.
For driving on the field, we have functions that use the shaft encoders. The program makes it so that the wheels continue spinning until the shaft encoder reaches the target value. For turning, we use the inertial sensor, and the wheels continue turning until the inertial sensor returns the heading in degrees of the value that we want. We use a function that uses the parameter for amount in inches and maximum speed in percent.
To help with programming, we are using bumper sensors in our intake to keep track of how many balls we have. When the bumper is pushed, the ball will be stopped.
For our rollers, we have 2 functions, neither of which have any parameters. One function starts the rollers, and the other one stops it using preloaded VEX functions.
Our function for intaking takes one parameter that is called amount, and it's an integer between 1 and 3. If the value is 1, the intaking will continue until the first bumper switch is pressed. If the value is 2, it'll continue intaking until the top bumper switch is pressed. If the value is 3, it'll continue spinning until the top button is pressed. Then continue for another 3/4 of a second to ensure that the ball has been released.
This is our route to score the home row goals. We will start with the preload and pick up the ball in front of us. We will then score a preload into the goal on the right. With our second ball that we have intaked, we will score that into the middle goal. With our third and final goal remaining on the left, we will drive there. As is shown on the field, there is a ball in our path. We will pick it up and score it into the goal.